Hello, Algebra 1. Today we're going to continue our discussion on multiplying binomials, where we're going to be focusing on three special cases that are very common, and we're going to be looking at each case one by one, and hopefully we'll notice some patterns as to the structure of the final answer. And so in this first example here, we're going to be looking at the square of a binomial sum. When you square something in math, you take it to the power of 2. A binomial has two terms, and the word sum implies addition. And so if you look at number 1 here, we have x plus 4 times x plus 4, which you can think of it, or you can rewrite it as the quantity of x plus 4 squared. And if you notice, x plus 4 is my binomial sum, right? I'm adding up two terms and I'm squaring it. And that's what we mean by the square of a binomial sum. And so the way we've been doing this is we've been creating a Punnett Square, where I would put x plus 4 here, and I would put x plus 4 here, and then we would just carefully multiply the terms out. X times x gives me x squared, x times 4 gives me 4x, 4 times x gives me 4x, and then 4 times 4 gives me 16. And then from here, you would just write down the 4 terms inside the Punnett Square. And then from there, we would just combine like terms. So I have x squared plus, and then here I have 4x plus 4x. Those are my like terms. So that would become 8x plus 16. And this would be my final answer. So one way to do this is by the Punnett Square, right? Using the Punnett Square. But what we notice is when we look at our binomial here, right? This first term, if you notice, if I square it, gives me this first term. So if I just took that first term and squared it, I would get that term right there. Another thing to note is that if you take this second term, which is this 4, and if you square that, you actually get the 16, right? So if you take that second term in the binomial and you square it, you get that constant at the end. Now, when you look at the middle term here, this 8x, let me actually color this orange. Hopefully you can see where this 8x came from. I added 4x and 4x to get 8x. And so what we notice, though, is that that 8x consists of two 4x's. How do I get 4x? I multiplied the first term of the binomial by the second term of the binomial, right? So hopefully if you look at these colors, you'll see where this x came from, and you'll see where this 4 came from, right? And you'll see why there's a 2 there, because there were two 4x's, right? There is a 4x here, and there's a 4x here. There are two of them. And that's how we get the structure, right? One thing I do want to mention, the last thing I want to mention here, is that there is a plus sign, right? There's this plus sign right here. And that's because we're dealing with a sum. So just keep that in mind, because later on when we have a difference, you'll notice that we'll use a different sign there. So this is the general structure, right? When you square a binomial sum, the first term of the binomial, when you square it, it gives me the first term. The second term of the binomial, when you square that, it gives me the last constant, right? The last term. And when you multiply these together and times it by 2, you'll get the middle term. And so this structure is what we're going to be using for problems like this. So if you look at number 2, we're going to follow a similar structure. Right here we have 2x plus 3 quantity squared. So I know that my first term will be 2x squared, right? And again, this 2x from here. I know that I'm going to have plus 2 times the first term of the binomial times the second term of the binomial. And again, this 2x comes from there. This 3 comes from this 3 here. And then lastly, I know that I'm going to take the last term and I'm going to square it, right? And so seeing that structure, right, I'm going to just carefully multiply this out. 2x times 2x is really 4x squared. Here, if I do 2x times 3, that's going to give me 6x, right? And if you do 6x times 2, that's going to give me the 12x. And then lastly, 3 squared, which is 3 times 3, is 9. And this would be my final answer. So hopefully you see the structure. I want you to pause the video and try number 3 on your own. And when you're ready, press play. So looking at number 3 here, I know that this is a sum, right? It's a square of a binomial sum. So I know that the first term will be 3x squared, again, because this is my first term. And I know that I'm going to be adding, because this is a sum, 2 times the first term of the binomial times the second term of the binomial. So again, when you look at the colors here, this 1, right, comes from this 1. And then lastly, you're going to add the last term squared, right? The second term squared. And so that becomes a 1 here. And again, just to emphasize, right? Make sure you see this plus here, and that's because we're dealing with a plus here, okay? Keep that in mind. The last term is always a plus. So this will always be positive, right? It'll always be a plus there, so there's nothing really to worry about there. But that middle term here, this is the one that's going to change later on, depending on what kind of special case you're dealing with. So just be careful there. Here, when you do 3x times 3x, that gives me 9x squared, plus 2 times 3x is 6x. 6x times 1 is still 6x. And then lastly, 1 times 1 is just 1. And this is your final answer. If you got that right, nicely done. If you made any mistakes, just be very careful and learn from your mistakes. One last thing I want to mention is when you're given something like 3x plus 1 squared, one thing some people try to do is they just try to distribute this 2 to both terms. So what they would do is they would write 9x squared plus 1. And my hope is you don't ever do this, okay? This is not correct. It looks right, but it's not. You cannot do this, okay? You have to always, when you're multiplying it out, think of it as you're multiplying 3x plus 1 times 3x plus 1, and that will avoid making this mistake, okay? And so when we look at case 2, we'll notice that this looks very similar to case 1. We have the square, right, of a binomial, but the key here is that we have a difference. And that's where things will change, right? We're going to have a difference. Earlier we had a sum. Here we're going to have a difference. If you remember a difference, you should be thinking of a subtraction sign. And so if you look at our example here, number 4, this is the same thing as x minus 5 squared. And hopefully you see that this is a difference, right? There's a minus here. And so when you do something like this, it's going to be very similar to what we did in case 1, where your first term will be the first term in your binomial squared. So let me change this, right? This x squared comes from here. And just like before, I'm going to have a 2 here. And I'm going to take the first term of my binomial, times it by the second term of my binomial, right? So this x comes from there. And then this 5 comes from my second term. And then lastly, I'm going to plus the second term squared. And so this looks very similar to what we did before. But the main difference is I'm going to put a minus right here. And that's where you have to be really careful, right? There's a minus there because we're dealing with a difference. And so when you multiply this out, you're going to do the exact same thing we did before, right? Just carefully multiply this out. X times x gives me x squared. When you multiply 2x times 5, you'll get 10x, so minus 10x, and then plus 25. And this is your final answer. So if you notice, there's a lot of similarities between case 1 and case 2. But the real main difference is this minus sign right here. You really have to watch out for that, okay? That's the difference between the two. And so looking at example 5 then, right? Following the same kind of structure, I know that this first term here, right, is 4x. And so I'm going to square that first term. And I know because this is a minus sign, right? I'm going to put a minus sign here, okay? I'm going to put a 2 just like I did before. I'm going to put the first term of my binomial and then the second term of my binomial. And then I'm going to plus 3 squared, right? So again, it's a very similar structure to what we've been doing, right? Hopefully you can see where that all comes from. And again, really be careful with this minus sign. It's so easy to forget, okay? And so when you carefully multiply this out, 4x times 4x is 16x squared. Minus, here I'm going to break this up into 2 steps. 4x times 3, that's just 12x, right? So we're going to have 2 times 12x, plus 3 times 3 is 9. If you carefully simplify this out, you'll get 16 squared minus 2 times 12x is just 24x plus 9. And this is going to be your final answer. So again, if you look at case 1 and case 2, they're very similar structures. The only difference is one's going to have a plus in front of the second term, right? And here we're going to have a minus. So really just watch out for that, okay? So at this point, I want you to pause the video because it is your turn to try number 6. So looking at number 6 here, we have the square of a difference. And so what I'm going to do is I know that my first term will be the first term of my binomial squared, right? And again, this 2x is because of that. I know I'm going to have a minus sign here, right? Because there's a minus sign here. And then it'll be 2 times the first term times the second term plus, right? This last term is always positive, second term squared. And so again, I'm going to just kind of color code this real quick. So you can see where these all came from. And again, this minus sign came from this minus sign here, right? If you carefully simplify this out, you should have got 4x squared minus. So here, 2x times 5 is just 10x. And so 2 times 10x would be 20x, right? So this becomes minus 20x plus 25. If you got this as your answer, nicely done. If you made any mistakes, please double check your work and make sure you're learning from your mistakes, okay? So we're gonna go to our final case. So we're gonna go to our final case here, which is case 3, where we have a, so we're gonna look at our final case here where we have a difference of squares. And we're gonna go right into this example, number 7, and then we'll talk about where this name comes from. So if you first notice, here I have a minus sign, here I have a plus sign. And I want you to notice that they're different signs, okay? If you also notice here, I have an x and an x, and those are the same, right? And I have 3 and 3, and those are the same. So if you notice, it's just 2 terms that are the same, but one has a minus in between, one has a plus, right? And so I'm going to actually do this using the Punnett Square. I'm going to put x minus 3 on top, x plus 3 here. Again, it doesn't really matter. I could have put x minus 3 on the left side. I could have put x plus 3 on the top, and it won't make a difference in the end. Multiplying x and x, I get x squared. Multiplying x and negative 3, I get negative 3x. Multiplying 3 and x, I get 3x. And 3 times negative 3 is negative 9. From here, I'm going to carefully just write down all the terms inside my Punnett Square. And then we're going to combine like terms. So x squared stays the same. Here I have negative 3x plus 3x, which by the way just becomes 0x or just 0. And I'm left with minus 9. This is my final answer. So if you notice, my final answer is actually a difference of squares, right? I have this minus sign here, right? This minus sign tells me that this is a difference. This first term is really just the first term squared, right? The first term of my binomial squared. This last term is just the second term in my binomial squared. And this minus sign represents the difference, right? And so if you look at where I got this first term, oops. If you look at where I got this first term, right? It came from the first term, right? They're both the same, by the way. If you look at where I got this 3 squared, let me use a different color actually for that. If you look at where I got this 3 squared, right? That was because that was my second term, right? And so this is why we call it a difference of squares, right? Because you're literally just taking a difference of 2 squares, right? You're squaring the first term in the binomial, you're squaring the second term in the binomial, and you're taking their difference, okay? So if I look at number 8 here, again, you should notice that same structure. I have 4x plus 7, 4x minus 7, and again, you make sure you have different signs, okay? So from here, I notice that because this is a difference of squares, it's going to follow that same structure, right? It's going to be a difference of 2 squares. I know my first square here is going to be the first term in my binomial, right? And I know that my second term will be 7 because that is the second term of my binomial, right? And again, don't forget the minus sign, right? Because we call this a difference of squares, right? Which means you're subtracting them. If you carefully multiply this out, 4x times 4x is 16x squared, minus 7 times 7 is 49. And that's your answer, right? So again, there's a structure when you're dealing with a difference of squares. At this point, it's your turn to try number 9. So once again, you see a plus, you see a minus, right? And again, they're different signs. You have a 2x, you have a 2x. You have a 6, you have a 6. So I know this is going to be a difference of sign, a difference of squares. And so when I multiply this out, I know all I have to do is take the first term squared minus the second term squared, right? So the first term squared minus the second term squared. 2x times 2x is 4x squared, minus 6 times 6 is 36. And this is your final answer. If you got this right, nicely done. If you made a mistake, just again, be careful and make sure you're learning from your mistakes. So at this point, we've gone over 3 different cases, right? And so in this last example, 10 through 12, what's going to happen is I gave you 3 problems, 1 for each case, and I want you to figure out what the case is and whether you can apply the appropriate structure for them. So at this point, I want you to go back and maybe look at the 3 cases that we just did, review each of them, and pay close attention to the structure. And when you think you're ready, try doing 10, 11, and 12 on your own. Okay, so looking at number 10, here what I notice is I have 6x minus 5 quantity squared, and so I know that this is going to be the square of a binomial difference. If you guys remember that structure, it's going to look something like this, and because we said this is a difference, right, this is a minus sign, I'm going to put a minus sign here. I'm going to have that 2, right, times something, and then the last term is always plus something squared. So we're following that same structure. Again, the first term is 6x. So I'm going to put a 6x here. I'm also going to put a 6x there as well, right? And then I notice that this 5 is going to go here and here, right? So I'm going to have a 5 here. I'm going to have a 5 here. When you carefully multiply this out, 6x times 6x is 36x squared, minus 2 times 6x times 5, that's just 30x. And then plus 5 times 5 is 25. If you simplify this out carefully, you get 36x squared minus 2 times 30x is 60x plus 25. And this is your final answer. If you got this right, nicely done. Moving on to number 11. Here, if you notice, I have 5x plus 2 and I have 5x minus 2. And so if you notice here, they're not the same signs, but they're different, right? So I know this is going to be a difference of squares. This is going to be the case 3 that we just talked about earlier. So I know that it's going to look something like this, right? It's going to be a difference of 2 squares, where the first term is going to be 5x quantity squared, and then this last term will be 2 squared. Again, you're going to carefully multiply this out. You should get 25x squared minus 4. This is my difference of squares. And then lastly, number 12, I have a square of a binomial sum. So I know that when I multiply this out, I'm going to take the first term squared. Now because this is a sum, I know I'm going to put a plus sign here. 2 times the first term times the second term of the binomial plus 2 squared. And if you carefully multiply this out, you should get 49x squared plus here 7. Oh, I made a mistake. That shouldn't be a 2x, right? This should just be a 2. Sorry about that. So if you carefully multiply this out, right, 7x times 2 is just 14x. And so this would be 2 times 14x plus 4. And then this will become 49x squared plus 2 times 14x is just 28x plus 4. And this would be your final answer. So if you got 3 for 3 right at the end, very nicely done. If you made any mistakes, again, just pay close attention to the structures and make sure you understand where you made your mistake. So this is the multiplying binomials with the special cases. Hopefully you notice each case and you know some of their similarities and their differences. And so my hope is when you do your homework, you'll use the structure to multiply the binomials out. Again, you can always use the Punnett Square, and that will always give you the correct answer too. But practice using these structures when you do your homework. Guys, this is multiplying binomials special cases. Guys, this is multiplying binomials special cases. I hope you guys are okay with this content. If you have any questions, please let me know.